So once you've taken out your taxes and you've got your NOPAT, then from a cash flow perspective, you add back any non-cash items. Depreciation is a non-cash expense, right? So we took it out up here to come up with the tax number, but then we add back depreciation down here to get to our actual operating cash flow. And in this example, in years 1, 2, and 3, that is going to be your final cash flow number that you just carry down to your final line down here. In year 4, you are ending the project. So again, we want to know what incremental cash flows we have from doing the project. So because you did this project, in year 4, you estimate you'll sell it for $25,000. Sell the machine for $25,000. But you don't get to keep all that. The machine is fully depreciated, so you have to pay taxes on this amount, which is your full gain. So in the end, your net cash flow from the salvage value is only $15,000. And then this is something the students have trouble with. Whatever you spent up here in year 0, you get back down here. So any of your net operating working capital cash outlay down here, you assume you get it back here. This is like you've got $20,000 in raw materials inventory every day of the project, and then on that very last day you still have $20,000 in inventory. You sell the machine, you send the $20,000 back to the supplier and get your money back. So your termination cash flow, or what the case also calls non-operating cash flow, because these cash flows are not from operations, they're basically from ending your operations. So your termination or non-operating cash flow is $35,000. So that is a number that you then add to the net operating cash flow up here to get your final project net cash flow. And once you have your overall project net cash flows, these are the numbers that you would put on a timeline, and we'll get the tick marks at year 0, year 1, year 2, year 3, and year 4. And then you use these numbers to calculate your NPV, your IRR, your MIRR, and your payback. For the case, again, you need to have a spreadsheet like this and have everything linked up. Don't type in any number, like don't type in 240. Have that be the sum of all these numbers. Don't type in 260. Have that be the sum of these two numbers. Have everything linked. Mainly for question 9, 10, and 11, when you go up here to change these inflation assumptions, you want to be able to have all these dollar amounts change so that your NPV and IRR and so forth will be updated. And also in the case, that are mainly concerned with NPV. How does it change when you change the inflation numbers? You can do NPV, IRR, and MIR, like I said, in Excel, just with Excel functions. So kind of carry those forward. Payback, I don't think there's really a function that does payback. If there is, you guys can let me know. But so maybe calculate payback for the first part of the case, questions 6 and 7. But don't worry about recalculating payback when you make changes to the inflation rates. And I would set it up like this. I would put your unit prices out like this, so that then when you have the inflation kick in question 9, you can then base your inflation, your increases, on this cell right here. So like for this cell, you'll have this cell be equal to this cell times 1 plus the inflation rate up here, and then this cell equals this cell times 1 plus the inflation rate that you have up here. So I have everything linked like that. Especially for, that'll help with case 13, which takes this exact same thing and has you change a bunch of numbers, has you put in a lot of different inflation assumptions, and then has you put in different price assumptions and different salvage value assumptions. So if you have everything linked up perfectly, case 13 will be no problem at all.